So for our week 4, we will discuss about intermediate SQL. This is for the second part of week 4. For this video, we will be discussing about integrity constraints, SQL data types and schemas, index definition in SQL, and authorization. So let's start with integrity constraints. Okay, so the concept of integrity constraints is not totally unfamiliar to everyone since we discussed this from our week 1 and we are already using it to create tables. So again, integrity constraints guard against accidental damages to the database, and this is by ensuring that authorized changes to the database do not result in a loss of data consistency. So yung mga example na very familiar kayo is setting the primary key and identifying that certain attributes are not allowed to be null. So, so there are other constraints that we can include in the definition of the table and specification of the valid values for the attributes. So for example, the amount must have a balance greater than something, or a salary of a bank employee must be at least 4.0 an hour, and then a customer must have non-null phone numbers. So you can include more. Okay, so here are some of the examples of constraints that are applied on a single relation, so on a single table lang. We are already familiar with not null, primary key, and then we are already familiar with the concept of unique, although yung unique dito is used for the constraint. And then we also have a new statement, which is the check statement given some predicate p. You can say that a particular attribute is not null during the creation of the table. Also, you can use unique constraints and say that a certain list of attributes should uniquely identify a record in a table. The unique specification states that attributes, let's say A sub 1 to A sub m, form a candidate key. So you need to recall the definition of a candidate key. In this context, candidate keys are permitted to be null, but the primary key shouldn't be null. Here we introduce the concept of the check clause. The check clause specifies a predicate P or some condition P that must be satisfied by every tuple in a relation. So for example, if we wanted to ensure that a semester is one of fall, winter, spring, or summer, and then in our create table portion of the SQL, we can specify a statement na ganitong itsura. So we have check the attribute semester is in the set containing fall, winter, spring, and summer. So if you're familiar with data validation in Excel or in Google Sheets, this is very similar to this condition. Bakit siya important? It's because it's the referential integrity. But unlike the previous types of integrity constraints, referential integrity uses two relations. So this referential integrity ensures that the value that appears in one relation for a given set of attributes also appears for a certain set of attributes in another relation. So for example, if biology is a department name appearing in one of the tuples in the structure relation, then dapat may mag-exist na tuple in the department relation for the biology value. So let's dig in and let's try to look at it in a set relation. So suppose we have a set A, and this set A is a set of attributes that is common to the two tables. So suppose we have R and S. So here we have A as the set of primary key of one relation, which is the S, and A is said to be a foreign key. Okay, so ibig sabihin nito, A is a subset of R if for any values of A appearing in R, these values also appear in S. So, dapat kung nandun yung record na yon sa R, yung nire-refer niya na record should be in S. So, to use this, we need to include one line that specifies the foreign key. So we can use foreign key, the name of the attribute references the table. So by default, a foreign key references the primary key attributes of the reference table. So in this case, department name is the primary key for the department. Also, SQL allows a list of attributes of the reference relation to be specified explicitly. So in this case, explicitly nakalagay si department name as the foreign key. There's a concept called cascading actions in referential integrity. So when a referential integrity constraint is violated, so yung previous condition natin was violated, the normal procedure is to reject the action that caused the violation. So just in case we have a delete or an update, ang mangyayari nito is that we can specify in the create table that whenever there's a record that is deleted, in the department name or in the course, then we need to update the child table. So yung something that references the parent table, in this case the parent table is the one that is referenced, which is department. So another way of dealing with updates or delete is just to set the value to null or set to some default value. So sometimes there are violations to the integrity constraint during transactions. For example, let's consider this table. The table person has an ID, the name of the person, the mother of the person, father of the person, the primary key ID, and then there's a foreign key that, okay, and then the mother and the father attributes here is a person as well. So we include the ID of the mother or the father. However, if we include the person without the mother ID or the father ID, it will disobey the integrity constraint. So how do we insert a tuple without causing such constraint violation? So either unahin mo muna yung father and mother so that meron na silang primary ID before you insert yung child nila. So another thing is you can insert the child, for example, and then you set the father and mother to null initially and then just update the record upon insertion of the mother and the father. Otherwise, you can just defer the constraint checking here. Instead of just using a simple condition or a predicate, the actual predicate can actually include a subquery. So, in this example, makikita nyo na this is not just a simple condition. In fact, merong subquery in this section. Meron tayong select from statement. So, ang nangyayari is that you are checking the validity of the time slot ID by querying another table. And the other table here is the time slot. So, in this case, time slot ID is in the section table and the time slot is another table. And this condition is checked whenever there's an insertion or modification in the table section. Also, when there's a modification dun sa na-try na i-query ng check condition, which is the time slot table. We will also introduce the concept of assertion. So this is another level of an assertion is a predicate expressing a condition that we wish the database always satisfy. So, ito yung mga constraints like for each tuple in the student relation, dapat yung value ng total credit must equal to the sum of credits of course that the student has completed successfully. So, For example, an instructor cannot teach in two different classrooms in a SEM in the same time slot. So yung mga ganong types of conditions or tinatawag na assertions ay pwede nating i-declare as an assertion with a certain name. So, yung mga conditions na yun, which are technically just a predicate, we can create names for it. So, we can say create assertion, the name of the assertion, and then the check statement, and then the condition. Let's move on to the next topic. And that topic is about built-in data types in SQL. So in this particular slide, I'm showing date time formats. So the first one is the just the date, and then this is using the format year, month, and date. Next is time, or the time of day in hours, minutes, and seconds. So triple yung time. And then we also have the timestamp. So the timestamp is the date plus time. And then we also have the interval, uh, which is the period of time. So let's go into the details kung kailan natin ginagamit ito usually. Timestamp is an example of a complex attribute because in timestamp, you can derive the date and then you can also derive the time. The timestamp is more convenient in computing the interval or the duration. However, if you wanted to utilize the date most of the time, then mas maganda na yung date na lang yung gagamitin for the data. The next data type is called the large object types. So sometimes hindi lang really structured data or in a tabular form yung ini-store natin sa databases. Sometimes we store photos, videos, yung mga other files na medyo malalaki pa like CAD files and so on. In fact, for big data, majority of the composition are data coming from machines na for every time point nagko-collect ng data. For example, like sequencing machines, satellite, and other IoT devices. So there are two types of large object types here. The first one is the blob or the binary large object. In this case, the content of the blob is some uninterpreted binary data. Most of the time, mga photos, videos, and CAD files to. And then another type of a large data type is the club, and this is referring to character large objects. So since the content of club are just characters, you can actually use any text editor to open the content of the club. Ano yung mga examples ng na gumagamit ng club? Genomic data, for example, it contains the sequences of the genes. When a query returns a large object, hindi yung buong object na yun yung nire-return at ipinapasa dun sa nag-query. Rather, yung pointer lang yung nire-return sa kanya. So aside from the built-in data types in SQL, we can actually define customized or user-defined data types. There are two constructs here, type and the domain. So let's start with the type. We can use it, for example, SQL statement create type dollars as a data type with certain specifications, and then using the type name, we can just call it in replacement of the data type. So budget now is described as dollars, and the dollars is equivalent to numeric 12 to final. And then we have domains. For the domains, we can now specify integrity constraints here. For example, like saying that this specific data type cannot be null. Other than that, we can specify check statements or some possible values for the specific domain. Our next topic is about index creation. So suppose I have 1,000,000 records and then I have 100 columns for the table. So many query references only a small portion of the records in the table. So hindi lahat yun tinatry yung i-search. So if we have, let's say, a naive algorithm for searching an element in the 1,000,000 by 100 records or values in the table, sobrang tagal nun. That is why they introduced the concept of indexing. So yung indexing dito, you can imagine that probably a very simple implementation of this is a hash table na may mga indices and then keys. And then you can specify that some attributes can be used for, you can select a few columns na most of the time mas gagamitin mo, so you will include it as an index. So by default, the primary keys are indexed because it is used for referential integrity, and most of the time if you perform some join operations, ginagamit yung mga primary keys. Aside from that, if you know that your application uses this specific attribute a lot, especially with select and specifying some conditions for some computation, perhaps we need to specify and create an index for that. But we have limitations on creating the indices. Hindi dapat lahat ng attributes mo ay may index. Magiging inefficient yung system. So we can create index using this statement. Create index, the name of the index on the attribute name. So let's give an example for the index creation. Suppose you wanted to create a table student and then meron siyang primary key na ID. We define an index called the student ID index on student ID. And then this query can be executed by using the index to find the required record without looking at all the records of students. So later on, you will see that there are different algorithms to be used for searching elements in a list. So, yun yung mga gagamitin natin. Our last topic is about authorization. So, note that we may assign a user several forms of authorization on parts of the database. So, pwede natin i-specify that this particular user is allowed just to view this particular table, is allowed to read and insert, update, but not delete a record, and so on. So the four basic authorizations we could assign a user is very similar to the file permissions that we have in our operating system. So we have the read, insert, update, and delete. Each of these types of authorization are called privilege. Each of this type of authorizations is called a privilege, and we may authorize the user all, none, or a combination of these types of privilege on specified parts of the database, such as a table or a virtual relation or a So modification of the database schema is also a form of authorization. So we can allow other users to perform indexing, resources, alteration, or drop. Yung index, it allows the user to create or delete an index. The resources naman, it allows creation of new relations or new tables. Alteration is allowing the user to add or delete columns in a table. And then lastly, some users are allowed to drop the table. So you can specify authorizations using the grant statement. So it is used by calling the grant keyword and then specifying the privilege on a specific table or a view to a specific user. So yung input natin dito is the privilege on a table to some user. We can specify authorization by using the grant statement. So the format of the grant statement is as follows. We have grant privilege list on relation or view to a specific user list. Yung user list natin dito, the valid values are either a specific user ID, the keyword public, which allows all valid users the privilege granted, or a specific role. So we will discuss role. So we will discuss the ro- the co- so we will discuss role in the succeeding slides. So here's an example. We have grant the select privilege on the table department to Amit and Satoshi. So notice that we can actually have a list, not just an element. So grant select update on department courses to Amit Satoshi. So parang pwede tayo magdagdag dito. Granting a privilege on a view does not imply granting any privileges on underlying relations. Also note that if we grant a privilege on a view or a virtual relation, it does not imply granting a privilege on the underlying relation, kung ano man yung ginagamit ni view. And then the grantor of the privilege must already hold the privilege on the specified item or the database administrator. Moreover, we discussed the different privileges in SQL. Select is allowing read access to tables or the ability to query using the view. Next is insert or the ability to insert records. Update, the ability to update using the SQL update statement. Delete, removing records. And then all privileges keyword is used to specify that all the four privileges are given. If we can grant an authorization to a specific user or a role, we can also revoke the privilege list to a specific user. So we can use the revoke statement here. So for example, if we don't want the if you don't want certain users to read information from the student table, then we can call the revoke select on student from this specific user list. And then the privilege list may be all to revoke all privileges the revokee may hold. So, tuwing kailan ginagamit yung revoking an access? Whenever we have, let's say, an employee that is no longer part of the organization, so nire-revoke natin yung access. Remember that we can grant access to users, to public, or to roles. Yung roles naman, this is a very important concept because we can hash each user to a specific role. Mas malinis din yung pag-grant ng access if mas malinis din yung Our next topic is about roles. Remember that we can always grant an access to a user, public, or a specific role. And then a role is a way to distinguish among various users. So you can actually think of it as a classifier. You can actually think of it as a class. You can actually think of it as a You can actually think of it as a classifier for different types of users. So, mas malinis yung pag-grant ng access mo depending on the role. It is actually a convention to grant an access to a role and then specify that the role of the specific user is this particular role. Here are the example of roles. We have create role instructor, and then we grant instructor to a certain user ID, for example, Amit. And then privileges can be granted to roles. So grant select on takes to instructor. So all users that have instructor roles will be granted this permission. And then roles can be granted to users as well as to other roles. So create role teaching assistant and then grant teaching assistant to instructor. So, mai-inherit niya yung mga different permissions na kayang gawin ng teaching assistant doon sa instructor role. And so, for this slide, hindi na lang actual table yung binibigyan natin ng grant access to some user ID or some roles. Yung create natin na views, bibigyan natin ng grant si instructor.